Hi everyone, my name is Maxime Chagnot. I'm a CATIA consultant working for PLM Technology in Norway. If you don't know me already, I am providing 3D experience tutorial on the PLM Technology channel on YouTube. And today I'm very honored to be part of the CATIA Talk program. And I will present you a pretty nice tool that is in Sketcher in part design. And this tool is called Animate Constraint. And we will create a 2D mechanism. Okay, so now we'll start by having CATIA. Okay, so this is CATIA 3D experience. So we'll perform a live demonstration of the release 21X. And as you can see, I already created a part. So it's called Mechanism Sketcher. And now I'm in part design. I will just select the plane and click on sketch or to create a sketch directly in the part. And now we are in Sketcher app directly. Okay, so the scenario is pretty simple. We're going to draw a piston rod mechanism in 2D, obviously, and we will just make animation of that. Okay, so the first thing I will do is designing the fixed part or the quarter of the piston rod mechanism. So here we have, as you can see, I'm using basic feature, rectangle and circle. These two rectangles here represent the quarter where the piston will be. So that's the piston chamber indeed. And here we are going to set up this value at 60 millimeters. So there is no problem for you to redo this scenario, by the way. Okay, 60. And the value of this element here are not that necessary, but we need to have a sketch that is ISO constrained. So we need this value. Okay, here it is. So what I can do also is select two elements and click on the equal function. And now we can say that these two edges are the same length. So we do the same in that way. Great. We need to finish that design by selecting the two edges. So what I do is doing external, external, and then select the middle plane to do a symmetry. So external, external, and middle plane here. I go to the constraint defined by dialog box and then select symmetry. Great. And I just finished by adding a distance between the center of our part and the edge of our chamber. And now you can see it's green, it's ISO constraint. And this circle here, you see, will be the emplacement of the engine, the motor for the piston rod. Great. Now I have made this first element, the quarter. So we'll just select everything, as you can see here, and I will select on this pin, on this paper clip, and select group. I create a group. Okay, you can even rename it. So here we can just say quarter, and okay, it's purple now. It's because we have our constraint, but that's not an issue for this type of design. Another tip I can give is to display the action pad, as you can see here, and also the object properties just under. So this you can see, you can remove, for example, the visualization of the ISO constraint or over constraint. And this will allow you to add color. So now let's move on the second part. We create the crankshaft of our piston rod assembly. So I will go away from this zone because I don't want to have any constraint creating in the same area. So I create two circles and a third one on top here. And you see here, if I just click here, it will be tangent. It's not what I want. So I just make it a bit bigger in order to have no extra constraint. And this vertical line here, I will transform into construction element. We will use it later. Excellent. These two circles I will put equal as I should before, and I'm going to put 10 millimeters as a diameter. And here it is. You see that you have the tangent, so it's no issue. We just click on the up arrow of your keyboard and you delete these tangencies. So you see the up arrow will show you the different connection. I just select tangency and delete. We can add the diameter of our crankshaft, and here too long, so I will put 40 millimeter. It's a bit hard to understand right now, but you will see after. It's going to be easy since it's a bit schematic for the moment. I select all of these elements and we will color that into blue. And I will again select the paper clip to get the second group that we'll call Crankshaft. Here it is. Let's continue in our design. I will make a piston rod. So I will make the rod like that. So we'll put a length of 100 millimeter and width of 10. And we will add the two connection here by creating two circle again. I select the equal. And as you can see, I'm using the contextual menu. It's very easy in Sketcher to use. It makes more efficient the new design. 10 millimeter, that is correct. I select all of that. I'm going to change this to a new color. We can put dark green. And this will be group number 3. And I will change it to road. And we finish by the piston. But the piston I will do on top here. I don't want to have any impact on the other. So I just go a bit away. It's very easy to work that way, actually. And I will make my circle here. I will also put a line in the middle as construction element because we can reuse it later. We put the two distance. So remember here, this will be the piston diameter. So we need to be the same as this one. So here's too big. So we put 60 millimeter. And this will be 10. This will be 40. That's going to be the length of our piston. I can move that inside. It's no problem. I can say that this hole is going to be 10 millimeter from the edge of the piston. Great, except that here it's not green. And the last thing we need to do, we saw it before, we need to do a symmetry. So external edge, and middle. And now I can go to symmetry again. That's good. It's not green yet because it's not set up in the origin here. So we will do it after. I just color that in yellow. And I select this as a group number 4. And I will change it to piston. Okay, so on this step here, we have everything. We have 4 groups of parts. We have the crankshaft, the rod, the piston, and the carter, or the fix, it depends how you see it. So we need to connect this element together. And we are going to move that directly in the sketch. I will select the bottom edge of the piston and the top edge of this carter and say that is tangent. When you say that is tangent, you have actually created a prismatic connection because now you can translate in this axis. Okay, let's continue. What you can do now is select the crankshaft and the 2 hole here and just say that they are concentric. Concentricity. And now you have made a revolute in the crankshaft and the fix. And let's finish with this one here by saying that this circle and this circle are concentric as well. But you will see here that we cannot have a connection between the piston and the rod because there is a tiny value here. It's a bit hidden. But if I click on the up, you will see here, if I click on my keyboard, there should be a parallelism. It's hard to catch here. You should parallelism. This is horizontal. And we don't want this row to be horizontal. So I just delete it. I select it too and do concentricity. Well, now we have everything, except that we have a tiny issue here. The vertical line of the crankshaft or the construction line is vertical, and we don't want it to be vertical. So I do the same technique. I delete that, and now I will add an angle. and that will be the value, that will be the constraint we will animate. So you select the middle plane, and here, this is 90 degrees. You can put 70, you can put whatever you want. You will see that the whole mechanism is now moving, but again, it's fixed. So what we can do now is just hide this color because we know it's working. So I click here, now we have the color. And you can also remove this constraint here. And this we can keep because we need to select this constraint here. So how do we do it? Now you have to go to the Analysis tab and the Action bar and select the option Animate Constraint. You have a small panel that pops up. And here, what it tells you is you select the value. So as you can see, I just selected it. The first value is 70, but we can just put 0. And the last value as 360. So now we know it's going to do a full round. Okay. The third parameter you need to put is the number of steps. This will it's just an increment, a visual increment. So it does not change anything on the speed. The only thing is, if you put low, it will make only 10 increment. And if you put 100, it's going to be a bit smoother. So I would put 100. Or you could put 260 if you want. It's no issue with that. Okay, I put 100, and I'm going to click Hide Constraint. And you can just click on the play button. And now you have your engine that is rotating. You can select also the option Repeat, so then you're sure that it's going to make full round all the time. Okay, so that's how we can make a 2D mechanism. But as you can see here, we have a tiny issue because the piston is actually touching the crankshaft here. So we have to do an update on our design. So what can we do? We know that now we have the group. We have to select the road, and you have to click on this small button here called Detach Group. And only when you have done that, you can modify the value of the constraint. So now we can put 130, for instance. And you can see now the road is longer, and the piston will not touch the crankshaft. So remember to attach the group again, and we will finish by animating this constraint again. 0, 0, 360, and 100. I can hide the constraint and play. And you can see it now. Here it is. The piston is not touching the crankshaft, so it's a good design. Okay, so obviously, this tool is only for 2D mechanism, and I will not recommend it to use it as a skeleton for an assembly. I would recommend you to use more engineering connection to do a skeleton. But what I really like with this tool, what I think it's great to use it for is, first, it's quite quick. I mean, I would say less than 10 minutes to make this assembly, and you can easily share it with some people. Second, it's very easy to use since it's in Sketcher. You just have to draw the shape you want and animate and connect them together. And finally, I would say it's a great tool to dimension the parts you want to have later in your assembly, and have a quick validation of the mechanism. So especially if you do 4-bar mechanism, things like that, it can be quite hard to get the good movement when you have the wrong dimension and the wrong angle. But this tool is just great for that. So I really recommend you to try it. You can just play this scenario again. It will be very easy to do. So that was it for me today. I hope this was good for you and you enjoyed it. Thank you very much. Goodbye.